Okay, this is chapter 8.4, proportionality theorems. Essential question, what proportionality relationships exist in a triangle intersected by an angle bisector or by a line parallel to one of the sides? What? What you will learn in this chapter section is use the triangle proportionality theorem and its converse, and use other proportionality theorems. So let's take a look. Okay, so here's example one, finding the lengths of a segment. So in the diagram, segment QS is parallel to segment UT, and there's the parallel markers. RS equals 4 and ST equals 6. QU equals 9. What is the length of RQ? Okay, so what you want to do in this situation, there's many ways you can set this up as long as you use the right sides, but I'm going to move this off to the side and just talk about this for a moment. So this is vertex R, and this is S, and here's Q, and this is the length 4. And the question is asking what's the length of RQ. So I don't know this length here. That's what we're trying to find, is this segment right here. So we know that these two sides are parallel. And we know that angle R is congruent to itself by the reflexive property. So ignore this line right here, if you will. So if I were to, let me see, how could I do this? I could erase that, but it'd be a lot of work, so I'm not. So pretend QS is not there. We're comparing RUT to RQS. Okay, so there's a couple of ways we can do this. So since we have side angle, side proportionality would prove that these two triangles are similar, then we can find the lengths of the segments. Okay. And since these two sides are parallel, then the sides over here, which would be transversals, are proportional. So what you want to do is compare what you're trying to find, RQ. So we're going to say RQ is to QU. So we're taking this piece over this piece equals RS over ST. Okay, so this piece over this piece. All right. So once we do that, we just substitute our givens. We don't know RQ, so I'm just going to leave it RQ is to QU, which is 9, and that equals RS, which is 4 over ST, which is 6. So when I cross multiply here, I'm going to get 6 times RQ equals 36. 9 times 4. Let me show that. You might be saying, where'd 36 come from? 9 times 4. Cross multiply. So simplify, superfly, 36. Divide both sides by 6 to get RQ by itself. And that goes bye-bye. And we get RQ equals 36 divided by 6, which is 6. Okay, or we could have just seen that 4 over 6 reduces to 2 over 3, and 9 over 6 also reduces to 2 over 3. Either way you look at it, this is how you do it. We found RQ because we set up a proportion of the two sides that create the common angle R. So now you should be able to do problem numbers 3 and 4 in your exercises. Okay, example 2 is solving a real life problem. On the shoe rack shown, BA is 33. So that is right here. I'll label that 33 centimeters. CB is 27. CB is right here. Let me change colors. Let's change to red. CB is 27. CD is 44. Okay. And finally, DE is 25. Explain why the shelf is not parallel to the floor. In other words, explain why BD is not parallel to AE. Okay, so we have 4 values. It's hard to see that green one, so let me move that. Oh, it's connected. That means Control Z. There we go. Let's just leave that. That's just 44 right there if you can't see it. 44. So what we're going to do is set up a proportion, and I'm going to take the left side. Now, keep in mind, the reason we can do this is because we have a common angle in two triangles, angle C by the reflexive property. I'm not going to break it away, but it's just like this problem here where you can drag it out and the angles shared when you have a side cut through a triangle. Okay, so this vertex angle is congruent to itself, and therefore we're using the side angle side similarity theorem. So we're going to set up a proportion. So I'm going to say CB over AB, or CB is to BA, as CD is to DE. Okay, so that's how we set it up. All right. So then I substitute in my given. So CB is 27. BA is 33. And that has to equal CD, which is 44, over DE, which is 25. This has to be equal in order for those two sides to be parallel. So if I can reduce this, 3 goes into 27 9 times. 3 goes into 33 11 times. So that's that reduced. And 25, 5 will go into 25. And 5 will not go into 44. So this doesn't reduce. And how do you ever check to see if something reduces or not? If you have a calculator handy, watch this. 44 divided by 25 equals 1.76. And then if you have one of these fancy calculators and you hit math, enter, it'll convert it to a fraction. And the fraction did not change, which means it cannot be reduced. So 44 over 25 can't be reduced down to 9/11ths. So they are not equal. So therefore, there is no proportional relationship, and therefore BD. So therefore, BD is not parallel to DE. Okay, so that is why the shelf is not parallel to the floor. The side lengths are not proportional. Okay, this is theorem 8.8, three parallel lines theorem. All right, so UV is parallel to WX and YZ. They're all parallel. If three parallel lines are intersect two transversals, the transversals line L and line M, then they divide the transversals proportionally. So in other words, UW is to WY as VX is to XZ. Okay, so if three lines are parallel going through two transversals going through two parallel lines, then the segments between the parallel lines are proportional. So let's take a look at that. Okay, so here's example 3 using the three parallel lines theorem. Let's use purple here. In the diagram, angle 1 is congruent to angle 2, is congruent to angle 3. They're all congruent. GF is right here. That is 120 yards. DE is 150 yards. And CD is 300 yards. That's right here. Find the distance HF between Main Street and South Main. So we want to find this plus this whole thing. So be careful how things are worded, but we have to set it up the same way we just had the theorem set up. So since triangle 1 is congruent to angle 2 is congruent to angle 3, those are corresponding angles on a straight line. That forces Main Street to be parallel to 2nd Street, to be parallel to South Main Street. Okay, those three lines or streets are parallel. Since those three lines are parallel, we can set up a proportion and say segment or street FG is to GH as ED is to DC. Okay. There's another way to do this in one step. I'll do that in a moment, but here's FG, so that is 120. 120 is to GH. I'll just leave it GH because we don't know it. And that equals ED, which is 150, over DC, which is 300. Okay, so there's our setup. So when we cross multiply, we get 150 times GH equals 120 times 300. Okay, so that will give us 150 times GH equal to 3,600, or 36,000, I mean. Okay, 12 times 3 is 36, and 3 zeros, 36,000. Divide both sides by 150. And I get GH equals, get rid of these zeros, and I don't want to use my calculator. 15, do it old school, 3600. 15 will go into 36 twice and give me 30. Subtract 6, bring down this 0, 0. 15 times 4 is 60. And there's another 0, so it's 240. So GH is 240 yards. Okay, so that's GH, 240 yards. The question says, what's HF? Well, be careful. So now we say HF, not HH, HF. HF equals, that's the whole thing, HG plus GF. So HF equals, now I substitute my givens. HG or GH is right here, and that is 240. 240 yards plus GF or FG, which is here, which is 120. I could have also used the diagram, 240 plus 120. So HF, the length of that street, equals 240 plus 120, or 360 yards. Okay, so there's the answer to the question. Find the distance between Main Street and South Main. Okay, so now you should be able to do problem numbers 17 and 18 in the exercises. Okay, so here's theorem 8.9, triangle angle bisector theorem. So it says if a ray bisects an angle of a triangle, then it divides the opposite sides into segments whose lengths are proportional to the lengths of the other two sides. So it's like, what? So this is ray CD. And it says if ray bisects an angle, so angle ACD is congruent to angle BCD, angle bisector, then the two sides are proportional. So what they're saying is AD is to DB as CA is to CB. Okay, so this piece is to this piece as this piece is to that piece. Okay, so that's what we're going to take a look at in the next example. So here we go. Okay, so here's example 4, taking a look at the angle bisector theorem. In the diagram, angle QPR is congruent to angle RPS. In other words, we have a ray. We have a ray right here that continues forever. So that's ray PR right there that bisects angle P, and therefore QR right here, whoops, and change it back to my pen. Woo. So then I can say QR is to, and what did it say? It said AD is to DB, okay? QR is to RS as PQ. This side over here is to this side over here, which is PS. Okay, so let me get rid of this ray. Goodbye. All right, so that's how you set it up. QR is to RS as PQ is to PS. Now all we do is substitute in the givens. It's very simple. Write the formula from the theorem, substitute the givens, and then you have an algebra problem. QR We don't know. But we know the whole thing is 15 and RS is X. So this is taking into consideration what is called the sum of segments. It's like if you have two pieces of something, then they add up to the whole thing. So let me explain that with two lines. So here's a black line, and then I will choose another line, and I'll make that segment blue. So here are two segments, different thicknesses. So let's fix that. Okay, so here are two segments. So if this segment here is 8 and this segment here is 9, then you know the whole thing is 17, or 8 plus 9. Yes? No matter what the lengths are, this piece plus this piece equals the whole thing. That's what we're doing over here. So I'm going to now change the value of what we have. We have 15. Okay. And we have RS. So if this was Q, what's going on here? If this was Q, and this is R, and this is S, so it's this side right here. I know the whole thing is 15. I don't know QR, but RS is X. Well, in order to find QR, I take the total and I subtract the other piece. So QR is 15 minus X. So if this was 5, 15 minus 5 is 10, and 10 plus 5 is 15. Got it? Okay, so that's how we're going to do this. So there are our values that we're going to substitute in. So what is QR? QR is 15 minus X. The whole thing minus the other piece. So it's that simple. RS is X equals PQ 7 over PS 13. Cross multiply 13. Don't forget your parentheses because we will have to distribute. 15 minus X equals 7 times X. 13 times 15. 15 times 15 is 225 minus 30 is 195. 195 minus 13x equals 7x. Make sure I did that right. I think I did. On 13 times 15, 195. Yep. Okay. So then I add 13x to both sides to get all my x's on one side. And I get these to cancel, and I get 195 equals 20x. To solve this, I divide both sides by 20, and I get x equals 2 goes into 19, 9 times. 9 times 2 is 18, with the remainder of 1. 2 goes into 15, 7 times, which is 14, the remainder of 1. And 2 goes into 10, 5 times. So 97.5. So the length of RS, so segment RS is 9.75 units. We just found RS, which is X. Okay. Use the given, always when you're done, read what they're looking for. If it said find X, we'd be done, but it doesn't. It says use the given side lengths to find the length of RS. So your answer should always end with what they're telling you to find. Segment RS equals 97.5 units. Okay, it didn't say inches, centimeters. So whenever it doesn't give you a unit of measurement, you always call them units. So RS is 97.5 units long. Okay, so now you should be able to do problem numbers 19 and 20 in your exercises. Okay, so that brings us to the end of chapter 8.4. Fairly short exercise, and 8.3 wasn't too long either. So that is a nice little treat before spring break for my class anyway. 2 short lessons. So here's the end of 8.4. Please do these problems, and 41 to 45 are review questions. So thanks for watching. Have a great day.